Now, if you've been reading through the books or you've been reading online, you'll notice that there are things that have modifiers to our variables. We're not limited to just integers or doubles. There's a whole sequence of values out there for us. So if you really want to know what's going on, we'll flip over to another website here in a second. But this is the website, c++.com. They've got a beautiful set of references out there. It's a really decent guide. And if you look at it, here it is. This is the first one, or the second one, I should say. Let's go back to integers. This is called climits. It's a header file. It shows up way up here. You have to include it if you want to actually use it and see what's going. Climits is the new C++ limit file. Limits.h is the old C file. Use climits for C++. And it gives us the definition of how big and how many bits are inside each of these objects. So you can see that, if we take, for example, integers, the integer min is a minimum value for the object of type int is guaranteed to be a negative 32,767. So that means in no matter what system, if it's following the standards for C++, you have between a negative 32,000 and a positive 32,000, more or less. It's minus 1 over here. So this gives you 32,000 plus or minus for a minimum type of int. If you take an unsigned int, you get the maximum value. It's a 0 to 65,535. It's 16 bits, 2 to the 16. So each time you see these numbers up here above the 2, the powers of 2, each one of those is telling you how many bits are inside these. Now, unsigned simply means we've taken that 16th bit, the one all the way to the left or all the way to the right, depending on how systems are implemented, and said, okay, that bit now contains no sign. So if it's got 15, we've taken one bit away and we've turned it into a plus or minus sign, more or less, effectively 0 or 1. Is it positive or negative? And then here we've said, well, we know it's only positive, so that pseudo looks like we've doubled the values. In reality, we've just gotten rid of the negative component and put them all on the positive side. Now, this is the standard sizes that are out there. So a long int or a long variable, the minimum value is 2,147,482,647 negative, and positive for the other side. The unsigned long is 4,290 some odd thousand, and away you go. A long is a really big number, 64 bits basically in size, 2 to the 64. So an unsigned long is really big. These are new, relatively speaking, but they've been around for a long time. What we've got are these keywords called shorts, ints, and longs. You don't see a lot of this anymore, and you'll see why here shortly. Notice here, these longs, the long max and ultra long, or for lack of a better word, unsigned long, comply with C standards of 1999, which only includes 2011. So C++ 11 is the only style that and later that you can use those in. If you're running in 98, it won't work. So what can we do? Well, we can actually take this value right here. This is the name of the macro constant that lets us figure out what our system really has inside of it. So we could actually just come into our system apparently I still have that in my buffer. So int min. And if you remember from the last discussion, things that are capitalized are constants. And we can run this and see what does my system actually have for the minimum integer value. The minimum integer value of mine is a negative 2 billion. If you look back at the value over here, it's a negative 32,000. What this is telling us is that inside my Mac OS X system here, that the value for the integer mins, our standard ints, is really what used to be the long value. It really does give me more values. So the default set for our integer min is this. This can change based upon the system you're working in. If you're working in an older system or in a hardware-based system, you may find that the compiler for those uses smaller values. It has to be at least this to meet standard, but it can be bigger, and it sure as heck was. So if we take this int min and we go back over here to an unsigned int max, unsigned int max, and we run that, you'll see there's our 4 billion. You've noticed, hopefully, when things start popping up, that it gives you some of the values of things out here. It tells you, that there are lots of specific sized integers out there to use. Why would you do that? Well, sometimes if your code is needing more space because it's running inside of an embedded system, you might want to stick to 8-bit or 16-bit integers. You might want to make them unsigned because you've only got positive values, you never have a negative value. So these are system design constraints that you put on based upon the requirements for the program. So when you run into these things, this is when this comes in handy, to be able to find out just what can your compiler on that system do. And then you'll know, hey, I can't put a 4 billion size integer into my regular int, even though it worked on my system, quote unquote, the IT favorite. What I have to do is go into my systems and say, okay, if I have this, what are my values? What are my ranges? And do I need to change from an integer to a long or something else like that? Now, you probably saw it back here. There's C float. These are the floating point values. Float.h, again, is the C. This is the C++ version. And it gives you all of the values, how big things can get. And there you go. You can actually see what's the max size, 1e to the 37 for a float, or greater. These things can be bigger. So if we take float max and double max, there's float max. And here's double max. And we run this. You'll see that our float max is guaranteed to be 3.4 e to the 38th power. Our double is to the 308th power. There's a lot of precision inside these numbers here. There's a lot of decimal points. How precise are they really? That depends upon input and a whole lot of mathematics. So this is just to show you that you can actually have different sizes of variables depending upon the system you're working with, and you need to size your variables accordingly. For the learning process in this intro course, ints and doubles are pretty close to all that we really need to worry about, mainly because the standard int is so big to begin with. But if you're writing code and you need it to be running faster, and maybe you need to put a whole bunch of instructions together, you know how big they are, we're talking more towards the assembly side of things, then you might want to adjust the size of your variables to make things run. But for now, just know, if you need to find out, this is a reference on how to go find out exactly what is available to you in the system that you're working on. What's your compiler? What is your system? And there you go. Enjoy it. Hope you've enjoyed this one, and we'll go on.